is an air handling unit in the back side of the chamber, consisting of a blower, an air heater, a cooling coil, and a humidity system. The air is sucked inside the conditioning unit, conditioned, and thrown out again. This is the refrigerator system. We keep the refrigerator system outside the room. It consists of two compressors, regular and standby compressor. There is copper piping connected to the cooling coil which is circulating the refrigeration gas. Whenever there is a refrigerant gas circulating inside the cooling coil, the temperature of the cooling coil is at 7 degrees Celsius. The chamber conditions are 25 degrees Celsius 60% RH, 30 degrees Celsius 65% RH, and 40 degrees Celsius 75% RH. The cooling coil temperature is 7 degrees Celsius, 7 degrees Celsius, and 7 degrees Celsius. If you want to set the condition of 25 degrees Celsius, 30 degrees Celsius or 40 degrees Celsius, when the cooling coil temperature is 7 degrees Celsius, we have to heat the air. We require air heaters around 5, 6 or 7 kilowatts to heat 25 degrees Celsius, 30 or 40 degrees Celsius. We do extensive cooling and then by means of heating, we control the temperature. When there is extensive cooling, there is extensive dehumidification going on. For example, if this air-conditioned room is set at 25 degrees, the humidity in this room will be around 60% RH. If you set the temperature at 22 degrees Celsius, the humidity will further drop down to 55% RH. In our unit, we are doing extensive cooling, resulting in extensive dehumidification. To counter that, we need to put on more humidity in the chamber. The humidity heaters are 3, 4 and 5 kilowatt each. In this condition, the compressor is running 100% of the time. There is continuous cooling going on in the chamber, and along with it, there is continuous dehumidification done by the air heater. This is how temperature is controlled in the chamber. The compressor is on 100% of the time, and you cannot switch on and off the compressor. This was the old method used by Thermolab. This is the walk-in type stability chamber. This is an air handling unit in the back side of the chamber consisting of a blower, an air heater, a cooling coil, and a humidity system. Same as earlier, air is drawn inside the conditioning unit, conditioned, and thrown out. We control the temperature of the chamber with the help of chilled water refrigerator system, known as the hydraulic system. This is an insulated refrigerator system. This is a regular compressor. This is the standby compressor. The cooling coil in both the regular and standby compressor, the insulated tank which is filled with water. With the temperature controller attached to it, this is an independent unit manufacturing in the factory. We can control the water temperature based on the chamber temperature. We can circulate this water in the cooling coil and bring it back to the tank. There is regular and standby pump available. Again, taking the ice age conditions, 25 degrees Celsius, 60% RH, 30 degrees Celsius, 65% RH, and 40 degrees Celsius, 75% RH. For 25 degrees Celsius, we have to set the hydronic liquid temperature at 14 degrees Celsius, and for 30 degrees Celsius, we have to set the water temperature at 23 degrees Celsius, and for 40 degrees Celsius, we have to set the water temperature at 30 degrees Celsius. The water temperature is the same as the cooling coil temperature. The cooling temperature is now variable: 14 degrees Celsius, 23 degrees Celsius, and 30 degrees Celsius. Now we have to take the temperature from 14 degrees Celsius to 25 degrees Celsius, 23 to 30 degrees Celsius, and 30 to 40 degrees Celsius, and not from 7 to 25 degrees Celsius, 7 to 30 degrees Celsius, and 7 to 40 degrees Celsius. For these temperatures, we don't require higher capacity heaters. For example, you set the chamber temperature at 30 degrees Celsius, the water temperature at 23 degrees Celsius, and the compressor will cool down the water, and when it is 23 degrees Celsius, it will switch off. If the water temperature rises to 24 degrees Celsius to 40 degrees Celsius, it will switch on again. The switch on time will be 10 to 15 minutes and switch off time is 30 to 40 minutes approximately. The pump will circulate water inside the cooling coil. As the temperature difference is not much, the heater required will be 2 kilowatt, 1 kilowatt, and 1 kilowatt. Since our cooling coil temperature is not 7 degrees Celsius and is instead 14 degrees Celsius, 23 degrees Celsius, and 30 degrees Celsius, there isn't much dehumidification, and hence there is no need to inject more humidity inside the chamber. Hence, the humidity heater capacity are reduced to 1 kilowatt, 1 kilowatt and 1.5 kilowatt. If you compare the earlier air heater and humidity heater power rating in kilowatts with the current required kilowatts, there is more than 60% reduction in the electrical consumption. The second advantage is the wear and tear of the compressor. In the earlier system, the compressor was running 100% of the time, and in the new hydronic system, the compressor is running only 10 to 20% of the time. Hence, the wear and tear of the compressor has reduced and the life of the compressor has increased. These advantages were in terms of engineering point of view, but from an application point of view, the main advantage is the recovery of the condition when the power fails. For example, when the power fails, all the components shut down. The power is restored by means of a generator within a couple of minutes. All the components will start except the compressor because compressors have a time delay protection of 3 to 4 minutes. In these 3 to 4 minutes, the humidity inside the chamber will rise and hence the temperature and humidity will increase inside the chamber and you will get a deviation. For our new system, the power fails in store, all the components will start except the compressor. The pump will start immediately because it does not require the time delay. When the blower and the pump start, the already controlled temperature water with the time delay inside the system starts the circulation and the temperature will be well maintained inside the system. The advantage of using the hydronic system is that it reduces the electrical consumption by 60% and the water consumption by 90%. The wear and tear of the compressor is reduced by the fast working and recovery of the conditions. We have applied for the patent for this technology.